Hello, I'm Shadat Tamami and I'm going to be presenting our paper titled Challenging the Transformer-Based Models with a Classical Arabic Dataset of Quran and Hadith. The main objective of this work is measuring the performance of state-of-the-art models on a challenging task of finding semantic similarity in religious classical Arabic texts that are complex with underlying meanings that require deep human understanding. Moreover, classical Arabic is considered low resource in terms of available datasets. So our first contribution is a framework to build a classical Arabic dataset of related and non-related Quran verse and Hadith teaching pairs by consulting sources of reputable religious experts. Once we have this dataset, we evaluate monolingual, bilingual, and multilingual state-of-the-art transformer-based models to detect relatedness between the Quran and Hadith pairs. The standard approach of evaluating transformer-based models is basically by fine-tuning, then testing them on a dataset designed for a specific downstream task. However, recent research suggests that the common practice of using random split on the dataset inadvertently leads to data leakage from the training set to testing set, reaching 70% of instance overlap, which means the models are more likely to memorize data than generalize. Another limitation mentioned in the literature, which we hope to address, is that most existing datasets possess low readability index, which does not reflect real-world complex data. To address these limitations, first we created a new classical Arabic dataset of related Quran and Hadith pairs, since they are complex texts with embedded meanings, hence addressing the low readability index. To address the data leakage, we fine-tuned the models on the CoreSim dataset, which consists of Quran verse related pairs. Then we tested them in our Quran and Hadith pair dataset. To create the Quran and Hadith dataset, we used two sources. But in this presentation, I'll walk you through the framework used to develop the Quran and Hadith pairs from Fatawa or Fatawi, which are basically rulings on an Islamic law given by recognized authority, and many Islamic rulings or Fatawa use Quran and Hadith together as evidence. So this makes Fatawa a good candidate to extract Quran and Hadith related pairs. Now, bear in mind that throughout the presentation, I'll refer to the group of Fatawa, which is the plural form of Fatwa, as Fatwas. In this study, we use the Bimbaz website, which has an archive of a famous Islamic scholar fatwas that basically contain an answer to a specific question supported by a Quran verse and a Hadith teaching in many instances. So we extract all the fatwas, then take one at a time. Some fatwas contain several Quran verses and Hadith teachings to answer complex questions consisting of various topics, so the relatedness is not clear if taken out of context. Therefore, we collect only the fatwas which contain one Quran verse and one Hadith teaching to ensure they are related to a distinct topic. Then we extract the Quran verse and the Hadith teaching as a pair. Then we cross-reference the extracted Quran verse with the original Quran dataset extracted from Tanzil to ensure the whole Quran verse is incorporated. And for the extracted Hadith, we refer to the LK Hadith corpus, which can be found on GitHub, to get the full matan or the actual Hadith teaching. Then we ensure the pair does not exist in our dataset before adding it with label 1 to indicate their relatedness. And then we repeat the process to go through the whole collection of fatwas. Then to create the negative sample or non-related pairs, we follow this framework. We randomly select two fatwas, A and B. Then we extract and compare their topic tags to ensure that they don't share the same topic. And then we extract the Quran verse from fatwa A and the Hadith teaching from Fatwa B, and then we cross-reference it to get the whole Quran verse and the whole Hadith teaching or matan. And then we check if it exists in our dataset because we want all the pairs to be unique. If not, we add it with label 0 to indicate that they're not related. And then we check if we have a balanced data set. If not, we repeat the process to increase our negative sample until we reach a balanced data set, and then we end the process. Now, I finished explaining the process of creating the testing data of Quran and Hadith. Now I'll explain the process of creating the training or fine-tuning data of Quran verse pairs. For the related Quran verse pairs, we use an existing dataset named Qursam that consists of related Quran pairs extracted from Ibn Kathir book. And they are categorized into 3 groups based on the strength of the relatedness. In the study, we use the pairs categorized with strong relation. So they're 40% of the data set. So we extract these to be our Quran-related pairs dataset. So now to create the Quran non-related pairs, first we extract 2 random verses, X and Y, and then we extract the associated concepts from the Quran ontology. And then we tokenize the concepts into words, and then we ensure that they don't share common words in the concepts. And then we check if these pairs exist in our dataset. If not, we add it to our dataset as a negative sample or non-related pairs. And then we continue the process until we have a balanced set of related and non-related Quran pairs. Now this is the data set we have used in our experiments. So we have the Arabic Quran pairs that we have shuffled and divided into 80% for fine-tuning and training and 20% for validation. And for data augmentation, we have extracted the tafsir associated with these pairs from the tanzil.net, and there are 2 available tafsir, so this troubled our Arabic dataset. And also we extracted all the available English translations of these pairs, and there are 16 different English translations. So this is the English pairs that are going to be used in the bilingual model. And the all the translations of the Quran available in Tanzil have been translated for these pairs, and so this data set was used with the multilingual models. Now for the experiments, we have 2 baselines. The first one is using verse embeddings with cosine. So basically we convert the verse to a vector. And the way to do that is basically for every word in the verse, we extract its embeddings from a fast text model, and then we multiply that by its post-tag weight and multiply that by the ADF of the word. And once we got an embedding of each word in the verse, we sum up all the embeddings of the words to get the verse vector. Once we got the verse vector of the 2 pairs, we compute the cosine similarity. If it's more than 0.5, we assume that they are related. Now the second baseline is using the verse embeddings to train different machine learning models that classify pairs as related and non-related. And the best performing model was random forest, which we incorporated in the results table in the next slide. So here we show the results on the validation Quran verse dataset of 1024 pairs. The best performing models are the monolingual transformer-based models that are pre-trained on Arabic corpora and then fine-tuned in our Arabic dataset. And the best performing models of these are those fine-tuned on the Arabic Quran pairs with their associated tafsir. And the bilingual and multilingual models did not perform as well. Also, the baselines did not perform as well as the monolingual models. So we have taken the best performing models on the validation dataset and tested them with our Quran and Hadith dataset. And the best performing model is the Camelbird CA, which was pre-trained on a classical Arabic corpus and then fine-tuned in our Arabic Quran pairs with their associated tafsir. However, there's a drop of 20 points in F1 score compared to the performance on the validation dataset. To understand the result, we scrutinize the dataset, and as we see in the first example here, Hadith and Quran consist of different words except for one keyword that occurs in different morphological forms, which is yawlun and al-ila. But the model was able to identify the relatedness and predict one or related. However, many of the correctly classified pairs consist of a clear message, as in the second example here, while 70% of the incorrectly classified pairs have the label 1 or related, but the model fails to identify the relatedness and predicts 0 or not related as the label. This could be attributed to the fact that two texts consist of different words but have the same underlying message, as shown in the third example here. Also, many hadiths are a narration of a detailed incident that has a moral behind it, while the Quran states the explicit guidance, as shown in the fourth example here. So the analysis leads to the following conclusion. For the machines to capture the underlying meaning in the Quran and Hadith, it might be more possible through a knowledge-based approach. However, creating such resources is expensive, and utilizing deep learning models could be the alternative. So this is the end of the presentation, and thank you.